Walmart.com, Amazon.com, and other e-commerce sites are cataloging programs. What you see when you view one of those sites is the result of a JavaScript application which communicates with a server-side program. Any update to the inventory in the database is automatically reflected in the content of the web page. The cataloging program which I've designed includes a music application as one of its two tiers. The user is able to create playlists by sorting through genres, artists, albums, and then selecting any of the songs from those albums. As the user browses the catalog, the application prevents playback interruption of the music by handling all of the HTTP requests asynchronously. The crux to this method is that the browser never accumulates history. To facilitate the navigation function of the browser, the e-commerce application has been equipped with two navigation systems which operate independently from one another. Along with this feature is the ability of the application to recognize when the user is successively requesting the same information. The application prevents these unnecessary requests, but also facilitates the refresh function to account for when the user receives an incomplete page. This program also collects page ID values and the amount of time in milliseconds during which the user views each page. Upon completion of a transaction, the application separates the order according to which suppliers supply which portion of the order, and appends the behavior record to the database. As the user views a department, category, subcategory, or item type, the page ID values which he or she has accumulated are sent to the server along with the request. A marketing algorithm queries all of the items in the class which have been sold, and compares those values to each of the behavior records of the customers who have bought those items. Each time there is a match of a page value, the application accumulates the corresponding time value of the previous customer. An example of the complete criteria of one of those items would be an item number, the quantity which has been sold, and an amount of milliseconds during which the customer who has bought the item has viewed pages the current user has viewed. Thereafter, the algorithm sorts the results by the time value in descending order, and then by the quantity which has been sold, where two time values are equivalent. If the user is viewing a single item, or has items in the shopping cart, then the algorithm selects items for comparison a little differently. If the user is viewing a single item, then it finds all of the transactions in which the item has been sold, and then the other items of those transactions which are in the same category. If the user has accumulated items to the shopping cart, then unless the user is viewing a single item, the application evaluates each of the items in the shopping cart in that manner, and aggregates the results before sorting. The application also includes other miscellaneous features. If you have used Google, then you have also likely seen the search suggestions as you typed your search criteria, and should be familiar with what you are seeing in the video. During the checkout process, input mask functions insert the dashes into the phone number, card number, and social security number input text boxes as the user types. After the pre-checkout and checkout forms have been completed, the user can click a Submit button to validate and confirm the data before continuing with the transaction. Once a transaction has been completed, the order is forwarded to the appropriate supplier's email address, and a receipt of the transaction is sent to the email address which the customer has provided.